And just to get you guys started on this table of secants and wondering what might be asked of you on this particular sheet, well, the table is for f of x equals x squared, like the parabola we did in class. And it says, all right, let's get the secants closer to x equals 1. And so we start with from 2 back to 1. So I'm going to give you a little graph like we did in class, roughly off to the side here. Here's x equals 2 and x equals 1, and we have a secant line between them. What we're doing is closing in on that. We're getting closer and closer. The secant lines are getting closer and closer to 1. It's a pretty rotten drawing. Let me give you one more shot at it. We had 1, 2. That secant line gets closer and closer and closer. And what that table is doing here is picking points closer and closer and closer and closer to 1. So the secant lines we come up with are in turn getting closer and closer. So if I do at f of x at 2, the actual value f of 2 is 4, because we're dealing with x squared. So, and we're trying to compare it back to x equals 1. So when I say, and by the way, f of 1 squared is 1. So if I'm talking about rise, we're talking about 4 because 2 squared is 4, minus 1 because 1 squared is 1, over run, which is the x values of 2 minus 1. That's all there is to it. We're going to, if you just follow, that gives us a slope of 3 because that's 3 over 1. Next one is 1.5. When I take that squared, because we're dealing with the x squared graph, minus 1 squared, which is 1, to get your rise, and the run is using the x values 1.5 minus 1. And if you do the ratio of those two, rise over run, you get 2.5. Next one, you do 1.1, square that, minus 1, and then so on. You want to take and make your way down. And if you notice, the slope just keeps approaching. It's descending each new value of x that you put into f of x and complete this table. What I'd like to know is, by the time you get to here, right before you get here, what the value of the slope is at 1. Actually, it's going to be this last one here that's going to be really descriptive about exactly what the slope of your tangent line is. And then I went ahead and filled in the other blanks as well. Why can't you find the tangent line between x equals 1 and x equals 1? Because the run would be 0 and we'd be dividing by 0. Secant lines use 2 points. Tangent lines use 1. What's your best guess for the slope of at x equals 1? Well, that's what you're going to get from this second to last column. That'll be a pretty good estimate, that bottom slope there, of what the slope is at x equals 2. And then it says here, use this analogy. Basically what it means is I can't tell you how fast I'm going at 11 a.m. unless I know a little bit more about what's going on around 11 a.m. I have to get in a little bit more detailed and that's what this table's all about. So that's the general idea of this table. Feel free to fill it in and kind of see what that slope is, and then go ahead and use the derivative we learned in class, which, by the way, f prime would be 2x. So if you put 1 into 2x, the derivative, we get 2 times 1, which is 2. So what you're going to find out in these table values, if you keep calculating the slopes, you're going to get closer and closer and closer to 2. Hope that helps get you over that little bit of a hurdle. Let me know if there's any other questions.